This is the Chevy engine experiment. The objective of this experiment is to determine the pressure, volume, and temperature entropy diagrams for the engine idealized to the air standard Otto cycle, also to determine the characteristic performance of the engine, such as brake horsepower, brake specific fuel consumption, and the thermal efficiency of the engine. And to perform a complete energy analysis of the engine. This is a spark ignition engine. What we have here is a 6-cylinder Chevy engine, which is stripped of the auxiliary equipment. It's connected to the tap water, which is used for the cooling. And it's also connected to the dynamometer on this side, which is used to measure the torque and the power of the engine, as well as applying load to the engine. Basically, in this experiment, we run the engine at 3 different throttle positions, at a quarter throttle, at half, and then at full throttle. And at each throttle, we're applying the maximum load to the engine. So we try to keep the engine RPM in the range of 1400 RPM. Everything for this engine is controlled right here. So again, this is the throttle. This is how the dynamometer is controlled. So we apply load using the knobs in here. Over here we have the thermometers. Basically, this one reads the temperature of cooling water in. This one reads the temperature of cooling water out. And this one reads the temperature of the exhaust gases. All the temperatures measurement are in degrees Celsius. We use this gauge to measure the intake manifold vacuum pressure, which basically measures the vacuum inside the cylinder during the intake stroke. We also read the engine, the load applied to the engine from the scale right here. Other data measured for this engine include the engine RPM. We use this strobotech or strobe light to measure the engine RPM. Right now the engine is not running, but when it's running, basically what we need to do, we need to adjust the frequency of light. So when you turn this on, as you can see, it flashes light. So you basically focus the strobe light on the drive wheel, which is the red one down here. And as you can see, let me just turn this off because you can't see anything right now. But there is a white block on the drive wheel. So what the strobe light or strobe does is that as you adjust the frequency of the light, it stops, it frees the motion, the rotational motion of the wheel. So basically, you'll see that block stops moving. And what you read in here at that moment, that would be the engine RPM. You just have to be careful to see only one stationary block. If you have multiple, it means that the value that you see here is a multiple of the engine RPM. We're going to demo this when we're running the engine. Let's go over how the fuel flow rate is actually measured. The fuel for this engine is gasoline. And we use the setup on this side to measure the fuel flow rate at each run. So basically, as you can see, the engine's connected directly to this main gasoline tank through this line right here. So basically, this valve, when you close the valve, it cuts the fuel, and when you open it, basically, it allows the fuel, to be received by the engine. The engine can also receive the fuel through from this graduated cylinder. This is a 1,000 milliliter graduated cylinder. As you can see, it's initially filled with the gasoline. And this valve actually controls that. So when we're running the engine, basically what we need to do is, and when we want to measure the fuel flow rate, we need to cut this line. So you need to bring this valve to vertical position. So completely stop this line, and then you need to open this one all the way. Then the engine starts receiving the fuel from this graduated cylinder. We need to use a timer. For each run, we measure how long it takes for the engine to consume 300 milliliters of gasoline. So you start your time. You can start at 0 and then stop at 300. If you miss this line, no worries, you can start at 50 and then go to 350, stop at 350. When you're done, if you want to refill the cylinder, all you need to do is open the valve to the main tank and turn the pump on. That would refill the fuel, and that's it. The last thing that we need to do is measure the water flow rate. The cooling water, the flow rate is constant the entire experiment. So we're going to do this at the end. So basically, all you need to do is, first of all, this is the bin on the scale. It's on 0. Initially, you have to make sure that the valve is closed, so you're not losing any water. And when you're ready, just bring the hose up, put it in, start the timer, and do it for 1 minute. And then take it out. Basically, the rate of the cooling water, that would be the rate of the water in pound mass or pound per minute. Okay, so let's now do a demo. So we're going to start the engine, yes please, and then let it warm up for a couple minutes. And we're going to do this at half throttle. just demonstrated one run. We ran the engine at a quarter throttle. There was about 45 pounds of load on the engine. We repeat the same for the half throttle and the full throttle. And don't forget to wear the safety goggles and the ear protection while we're running this engine. We're going to collect the data at the end and then share the data with everyone and use it for the calculation.